Good morning. My name is Shodhan Prakash and my registration number is 13BCE0664. This is my digital logic assignment and the questions assigned to me were as follows. I will be solving each of the question individually and the solution will be from the chart paper I have solved on. So the first question is construct the truth table for the given Boolean algebra. We need to prove the commutative law, the associative law, the distributive law, the absorption law, the De Morgan's law, and the consensus theorem using only truth tables. So the solution to the first question is here. Okay. In the first part of the first question, we are asked to state the truth table for the commutative law. The truth table will be something like this. For inputs A and B, we'll have A dot B and B dot A. So for any of the inputs 0, 0, 0, 1, 1, 0, 1, 1, A dot B, we get 0, 0, 0, 1, and in B dot A we get 0, 0, 0, 1. So since A dot B and B dot A are equal, this proves the commutative law. Next question is to state the distributive law using the truth table. Say we have three inputs A, B, and C, and we have A into B plus C, and we have AB plus AC. Now for any set of inputs, say 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 2, 3, 4, 0, 0, 0, 1, 1, 0, 1, 1. So for any of these inputs, we have 0, we have 0, we have 0, 0, 0, and 1, and 1, and 1. Now, to see how we got this, we can simply do B plus C first. So B plus C, 0 plus 0 is 0, and then we multiply with an A, which is a 0, so the output is a 0. Similarly, we fill in this side of the table, and as you can see, this part and this part are same. Hence, the distributive law is proved. Next question is to solve the truth table for the absorption law. Now the absorption law states exactly this, that A is to B must be equal to A is to A exclusion B. Now if we solve the truth table for A is to B, we get, and if we separately solve it for this, we get. Now as you can see that this is equal to this, absorption law holds. Next part is to prove the associative law. Now, as we can see, A dot B dot C, B dot C in brackets must be equal to A dot B into C. Now, first solving A into B dot C, we initially solve B dot C, that is 0 dot 0, and multiply it 0 and fill in this column. After filling, we should get, and then solving this similarly, we should get, and since this and this are equal, the associative law is proved. In the next part of the question, we have to prove De Morgan's law using the truth table. So here I am going to fill out the inputs, and De Morgan's law states exactly this, that a plus b the whole complement is equal to a complement dot b complement. Okay, now for the inputs 0 0 0 1 0 and 1 1, we have a plus b the whole complement as 1 0 0 0, and as we can see that the solution of a complement dot b complement is the same as a plus b the whole complement, and since these two columns are equal, De Morgan's law holds true. Now we have to prove the consensus theorem using the truth table. The theorem states that AB plus A dash C plus BC must be equal to AB plus A dash C. Now using the truth table, we plot the solutions for this equation under this column, which gives us and AB plus A dash C also gives us, thereby showing that this is equal to this and hence proving the consensus theorem. Now I will be solving the second question, that is the 79th question assigned to me. The question goes, convert the given expression in the standard SOP form. The expression is f is equal to AC plus AB plus BC. The solution of the given question is here. Okay, now to solve the 79th question, we must first fill in, we must we must first fill in all the letters that are missing to complete the variables in this. So suppose it is AC, we can write it as A into B plus B dash C plus AB into C plus C dash plus A dash into BC, and so on. And then we see that the function is the SOP of 3, 5, 6, 7. Suppose this is A and this is B and C, 0 0 0 1 1 1 1 0 0 and 1. We see that according to this is the equation. Now this should be equal to product of 0 1 2 4, that is equal to A dash plus C dash into A dash plus B dash into B dash plus C dash, and this is the converted POS form. The next question, that is the 81st question, is to convert a given expression to the standard POS form. The given expression is f is equal to a plus b into b plus c into a plus c. The solution to the following question is here. In solving the 81st question, this is the given equation and this is the final answer. Here we see that we've taken a complement of the function to obtain the required SOP form, whereas here in the question it is in the POS form. For the 82nd question, we have the equation. We have to prove that f of ABC, the sum of minterms of 0, 1, 3, 4, 5, 6 and 7 is equal to the sum of max terms of 2 and 5. This is the solution for the 82nd question. Now in this question, we are asked to prove the following. We are given that a function f, which includes the variables a, b, c, is the sum of the min terms of 0, 1, 3, 4, 6, 7 must be equal to the sum of the max terms of 2 and 5. So now this can be written as summation of min terms of 0, comma 1, comma 3, comma 4, comma 6, comma 7. Now plotting this on a K-map, we get, see, this is A and this is B and C. We have 0, 0, 0, 1, 1, 0, 0, 1. Now we see this is 0, 1, 2, 3, 4, 5, 6, and so on. You know how we count the K-maps. Now plotting this on the K-map, we get, so now grouping it, we see that F is equal to B dash C dash plus A dash C plus AB. Now taking a complement, it is equal to B plus C into A plus C dash into A dash plus B dash, which is equal to the max terms or sum of max terms M2 and M5. Hence proved. This is the 83rd question. In the 83rd question, we have to plot the Boolean expression y is equal to abc dash plus abc plus a dash b dash c on the K-map. This is the solution. In this question, we are asked to plot the given expression on a K-map. Now, as we can see that it's 3 variables, so it'll be a 3 variable K-map having 8 squares. Say this stands for A and this stands for B and C, and marking the regular K-map markings, we need to plot A, B and C dash on this. So that would be this, this and this. So we can group it in the following manner and simplify it. The 84th and the 85th expressions, the 84th and the 85th questions require me to solve two equations. In the 84th, it is in the POS form, and in the 85th, it is the SOP form. So here are the solutions for the 84th and the 85th questions. Now in the next question, we are given the following equation and asked to plot it on a K-map. Now we can see that this is in the pi form or the product of sums form. And there are 4 variables involved, A, B and C, A, B, C and D. So we'll have a 4 variable K-map with 16 squares. And then we go about marking. So the same markings. And then based on this literal, now this is A plus B plus C plus D dash. Now A is 0, sorry, A is 1 and A dash is 0 and so on. So matching with our terms and this condition over here, we have to plot zeros in the following columns. In the 85th question, the 86th question of my assignment is to minimize the given expression, and the given expression is y is equal to ab dash c plus a dash b dash c plus a dash b c plus a dash b dash c dash. This is the solution of the given question. Next question, we're supposed to Suppose to simplify the given expression. Now this is the given expression. Now we notice that this and this have a dash, b dash, and c dash common, right? This have These two have a dash and b dash common, so we can take them out and take them common and write it as c plus c dash. And then we also notice that ab dash and ab dash are common in these two, and we take them common and we can write it as c plus c dash, and we'll be left with a dash b c. Yes, we'll be left with a dash b c. And now we know that c plus c dash is equal to 1. So this is equal to a dash b dash plus ab dash plus a dash bc. Now we can see that b dash is common in these two. So we can take that common and write it as b dash into a dash plus a dash bc, which gives us b plus a dash bc as the final answer. And in the last question, I have been given a state table and I need to reduce the following state table and draw the state diagram. Now I will be drawing the state table and also drawing the minimized state table, and then showing you how to draw the state diagram. So here's the solution. So for the next question, we are given the following state table and we are asked to minimize it and then draw the state diagram. Now as we can see from this table, E and G are completely similar since they have the same corresponding next states and the output states. So now we have E and G common. So E and G can be replaced interchangeably. When we replace this E with a G, we get D and F state to be a common state. So now we have the minimized state table. We have the minimized state table which says A, B, C, D, E are the only different states, and these are their corresponding next states and outputs. Now we also have to draw the state diagram, which will go something like this. Now as we can see from the table, at A it goes to A itself when x is 0 and the output is 0. So you similarly like this we fill up the state diagram table to get the following table. Hence this will be the required state diagram for this state table. Thank you for watching this video. I hope my answers were correct, and I hope I made it look presentable. My name is Shodhan Prakash and my registration number is 13BCE0664. Thank you.